Okay, pre-calculus. What are we doing? We're doing lesson 6.4. So if you have your book at home, you can read section 6.4. And it deals with radians. And I don't want to over-explain this time, so I'm not going to go into a lot of depth about what a radian is. But radian is just the measure of the arc. So I could call that, well, this is 3.14 radians. That's 6.28 radians. It's how long is the arc. There's a word for that. It's called circumference. You know this. Some basics about radians. I almost said radicals. You know why I almost said radicals? Because that was the lesson I just taught in trig. Radians. Bruh, why is my writing so filthy today? Radians versus degrees. Degrees are usually the measure of an angle. It is interchangeable though, so you can look at an angle and say that's 30 degrees, or you could say that's pi 6 degrees. You sound you sound pretty nerdy if you say hey, that angle is pi 6 degrees or pi 6 radians. But you could. This is section 6.4. First week of May. I know some of you are like 5 weeks behind schedule right now. Come on now. Playing with my emotions and your emotions too. So basics. We know that one revolution around any circle is 360 degrees. Doesn't matter the size of the circle. We know that the circumference of a circle is equal to 2 times pi times the radius. Oh, radius and radian. Why do those words sound the same? Okay, and since we're dealing with unit circle, we know the radius is 1. So, replace that r with a 1. You get this basic concept or equivalence. 360 degrees is equal to 2 times pi. Cut that in half, of course. Cut that in half, cut that in half. You get this basic equivalence. Bam! Both are important. This one is going to be real important because I'm going to show you a little shortcut later on. Look what that says. 180 degrees is equal to pi. This is true as long as the radius is 1. Cut that in half. Cut that in half. Bam! Cut that in half. Cut that in half. Half of a half is a fourth. Bam! And now, a little bit tricky. I'm going to divide this by 3. I'll explain why again in a minute. So divide that by 3. If I divide that side by 3, it's like an equation, right? I have to divide this by 3, and so it becomes 12. Which is why when we did unit circle initially, remember I taught you how to count by 12? Yeah, I know you remember. By the way, look at that. Equal sign goes straight. That's filthy. It's a good day. It's a good day. So, right in the middle, 45 degrees. 15 degrees later. 15. Yeah. And I don't know why students never notice this. Like, why do we skip this big? Why isn't it equally spaced? Well, it's because the coordinates at that point right there are crazy. You will learn that in the next chapter, by the way. But it really is going in 15-degree increments. So, bam, 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 bam. Don't forget these. Don't forget the corners. Bam. Okay, cut it in half. Bam. A little bit this way. Bam. A little bit this way. Bam. And then cut that in half. Bam. Bam. And cut it in half. Bam! So what you want to do before you even attempt this next assignment is make sure you got a filled out unit circle in front of you, okay? Now you can make it yourself if you're feeling extra motivated, or you could just print one offline. You can use the one that's in your journal. Yeah, you thought I forgot about that. No, I didn't, suckers. Okay, so each 15-degree increment is equal to a 12th. So this is 1/12. This is 2/12. By the way, so I'm really talking about how long is this piece of the circumference. So that's 1/12 pi. There's 2/12 pi. 3/12. 4/12. 5/12. 6/12. 7/12. 8/12. 9/12. 10/12. 11/12. 12/12. 12/12. AKA 1 pi. Yeah. 180 degrees is equal to 1 pi. Right there. 180 degrees, 1 pi. 13, 14/12. 15. 16. 17, don't care. 18/12. 19, don't care. 20/12. 21. I forgot how to count for a second. And 22. 12. And 23. And 24. When you get back to here, you better be at 24. It's like 24 hours in a day. 24/12. 24 divided by 2 is 2. 2 pi. Blah, blah, blah. Now, converting. We know that this is equal to 15 degrees. We have it right there. We know that this is 30 degrees right here. 30 degrees is equal to 2 pi 12. 45. 60. 90. 120. 135. 150. 180. 210, I almost messed up in pen. 225. 240. 270. 300. 315. 330. And back to 360. So you can call this 0 degrees, or you can call it 360. Or you can call it 2 pi. Or you can call it 24 pi 12. That was hard to say. Okay, so now on the assignment, there's 20 problems, and some of them are going to be real easy. Like if I say 240 degrees, how many radians is that? You just go blah, 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 240. That's 16 pi 12. You just write 16 pi over 12. I will count that correct. Will I be happier if you reduce? Yes, I will. Yes, I will. Reduce. Yeah. So many of the problems are gonna be that simple. So even though there's 20, don't be afraid. Some of them will literally take you a second to do. And then there's problems where you go backwards, where we give you the radian. This might take you 2 seconds. Like if we tell you 5 pi 6. Well, unfortunately, we didn't count in 6. We counted in 12. So what you're going to do is make this into a 12. How you do that? Multiply by 2. Multiply by 2. That is the proper way to show work. By the way, you in pre-calculus, you better show some work, right? Shoot. So you get 10 twelfths. Where is that? Right there. That's 150 degrees. Bam! So simple. So many of the problems, I'd say most of the problems, are going to be that simple. Might take you 1 second. It might take you 2 seconds. Yeah. We're at the 9-minute mark. So I'm going to continue this. I'm going to call it part 2. YouTube don't like me to go over 10 minutes.